Welcome back, Physics 30. This is the second part to FI2.1, looking at Coulomb's law. When calculating with Coulomb's law, we usually use magnitudes, ignoring the signs of the charges, and then worry about it after to see if it's attractive or repulsive. So don't worry, don't get blown away by negative signs or positive signs. We'll look at it after. So let's look at an example here. Electric force on an electron exerted by a proton. So determine the magnitude and direction. So we're looking for how big is it and in what direction will the force be exerted of a hydrogen atom exerted by the single proton that is the atom's nucleus. Assume the average distance between an electron and the proton is 5.3 times 10 to the minus 11. And we're looking to the force on the electron. So of course, we have a proton pulling on an electron. We know that opposites attract, so we know that the force is going to be in this direction, attraction. We know it's going to be attraction, right? Because we know it's a proton, a positive, pulling in an electron, a negative. So we know that that's what it's going to be. So we can look at this, F equals K, Q1, Q2 over R squared. So 9.0 times 10 to the 9 is what little k is. Now, the charge on a single electron or proton, of course we know one elementary charge, whether it's an electron or a proton, 1.602 times 10 to the minus 19 for both. And the radius of separation, or the distance between them, 5.3 times 10 to the minus 11, which will need to be squared first, right? So you have to square that, make sure it's in brackets. And when you type that in, so you can see we're dealing with small forces here, 8.2227 times 10 to the minus 8, and we can round that off to 2 sig figs, 8.2 times 10 to the minus 8 newtons. So there's the magnitude and the direction. So the force that the proton exerts on the electron is attraction. All right, so that's how you do that. All right, let's look at the last page here. So a couple of more examples. Determine the charge in coulombs of the following. Recall that a single charge, whether it's a proton or an electron, is equal to 1.602 times 10 to the minus 19 coulombs, and that 1 microcoulomb is 1 times 10 to the minus 6 coulombs. All right. So if we take a look there, there's also another thing here I should likely mention. We'll also run into millicoulombs, just like millimeter compared to meter. So we'll likely insert that here as well. I don't think I have it in this example, but I do in the assignment. So if I have, then look at how many protons we have, etc. So let's take a look here. So what is the charge if I have 4 elementary charges or a negative? So this negative here implies electrons, whereas here we can assume it's protons since we're not given in terms of a negative, but that's all right, don't worry about that. So 4 elementary charges, and then from earlier we know that right here, 1 elementary charge is that many coulombs. 1 elementary charge is 1.602 times 10 to the minus 19 coulombs. So cancel, and I get 6 times 10 to the minus 19 coulombs. If I'm looking at B, 20, and I'm just going to leave the negative off. Don't get too worried about that. Okay, what elementary charge? So multiplying that by 20, I get 3 times 10 to the minus 18 coulombs. So that negative there just simply tells me I'm dealing with electrons. And I could put a negative here, but I'm not going to. I'm just going to say in words, that's what the charge of 20 electrons would be. So I could write this, but don't get too concerned about that. 4 electrons. Vice versa, determine how many protons, how many electrons have. So C, this time starting off with 3.25 times 10 to the minus 17. Now I have a positive here, so we know it's going to be protons. So vice versa here. 1.602 times 10 to the minus 19 coulombs is 1 elementary charge. So this time I'm going to divide by that number. And dividing by that number, I think I get 230 elementary charges. Now, since this is positive, I'll say protons. D. Now notice I have a negative 1.25 times 10 to the minus 16. I'm just going to write down 1.25 times 10 to the minus 16. Then I'll worry about the charges after. Helps if I actually show you it too. There's 1 elementary charge. Cancel, cancel. So that gives me, I believe, 780 E's. Now, here I know it's going to be electrons. So I could either say 780 E for electrons, or I could say 780 E this way. It doesn't matter. The big thing is solving for it and then realizing after, okay, the charge on this originally was negative, so that means I have the overall charge will be negative 780 E's, or you can just simply say 780 electrons. And then one more here. We have to, first of all, determine how many coulombs that is. So negative 4.25 times 10 to the minus 10 microcoulombs. And that little conversion at the top here, 1 microcoulomb is 1 times 10 to the minus 6. So 1 microcoulomb is 1 times 10 to the minus 6 coulombs. So you may have to do that first to figure out what do we have in terms of coulombs. And what I could do, I should have just made this in one long line. My answer here will be in coulombs. Then I can simply multiply by 1.602 times 10 to the minus 19 coulombs is 1 elementary charge. So imagine this is just one big long line. Microcoulombs cancel, then coulombs cancel. And then I'll get my answer here. 2,652, I believe, I get for elementary charges. And I know that I had that negative there, so it's going to be electrons. Or I could just simply say negative 2,652 E's. It doesn't matter. Then, of course, there's 3 sig figs here, so I should have rounded that off to 3 sig figs. So 2,650 E's. Then I could just simply say electrons because of that negative sign there. So just be aware. Sometimes those signs are there, sometimes they aren't. Just be aware. Here I could have put negative 20 E, or I just simply could have said 20 elementary charges, which are electrons. So just be aware of that. So keep in mind that Coulomb's law gives the force on a charge due to only one other charge. If several charges are present, then we'd have to do vector addition, right? And then sometimes if you move on in physics, you will encounter that. This principle of superposition is based on experiment and tells us that the electric force vectors add like any other vector, just like when we talked about vectors. For example, if you have a system of 4 charges, the net force on charge 1, say, is the sum of the forces on charge 1 by charges 2, 3, and 4. The magnitude of these 3 charges are determined by Coulomb's law, so you'd have to do this for each one. So if I had, like, let's say 3, I'd have to look at the force between here and here, the force between here and here, the force between here and here, then add them all up. All right, so that's it, ladies and gentlemen. For the assignment, so you can look at the assignment, and then yes, on the top here, I had these little conversions here, which you may have to look at first. So there's some Coulomb's law type questions, and then there's some questions very similar to this. How many coulombs is 40 protons, or vice versa, giving you coulombs and figure out how many elementary charges are. All right, we'll see you again.